Welcome back, and we're going to look at variation in this video, and more of a mathematical perspective. We're going to get into some physical applications in the next video. So the two types of variation that we're going to see mainly are direct and inverse variation. You can actually combine them and then you get something called joint variation, but really as long as we understand these two, joint variation isn't going to be a problem. Okay, with direct variation and inverse variation, there's these four different ways to represent it. So let's tackle direct variation first. The verbal representation of direct variation is just going to be the language y varies directly as x, or y is proportional to x. So now we want to take that and translate that into the various representations, algebraic, tabular, and graphical. Okay, when we see this language, this proportional language automatically means that we have y is proportional to x, and so this is the Greek symbol alpha. This is just shorthand to say that it's proportional to, that it changes. So as y changes, x changes in the same manner. But really what it means here is that mathematically we get y is equal to kx, and k we call our constant of proportionality. Okay, and so every time you see this language of y varies directly as x, or y is proportional to x, you can think this that y is proportional to x with this Jesus fish, and that's how my physics teacher called it. But really it's just alpha. It means proportional to. And that we can't really do much with that mathematically, but this other form, y is equal to kx, is extremely useful to us. And so what we would see is, if we look at a table, xy, we would see that as we increase x, and I'm just going to do some funny numbers here, okay, what we would see is that, well, 1 is going to be k, and then this is going to be 2k, and then this is going to be 3k, and 4k. And so every time I move, so if I add 1 here, right, plus 1, plus 1, plus 1, as I increase the value of x, y ends up adding by this same amount, by k. But more importantly, what we notice is that there is a change. So as x changes, k or y changes in the same direction. That is, if I'm adding to x, y also adds. Okay, so this is another way of thinking about direct variation. Graphically, what we would see is that, well, if you think about this, this would be a graph of a line, right? Right straight through the origin. It has to go through the origin. If it does not go through the origin, it is not a statement of variation. Okay. And so we would just have something like this, or again, depending on k, you could have a negative slope too. Okay, just depending on what k is. K could be a negative number. We would have to find k in the instances, and so we have some examples lined up to do just that. Inverse variation here, the language that we will see, it's a little different, and what we would say is that y varies, and this should be not directly but inversely. We would see y varies inversely as x, and then also, I forgot, this is a typo, this should be y is inversely proportional to x. So again, thinking about this proportional language first, when we say y is proportional to, that's the alpha symbol, and then with inverse variation, it's actually, so it's a bit of a misnomer. I really want to call it reciprocal variation, because inverse students do weird things with inverse. But anyway, inverse variation here is 1 over x. Okay, and so similarly, just as you might expect, we're going to get our equation y is equal to k. We still have our constant proportionality, but it would be times 1 over x. Or, put differently, you can just say y is equal to k over x. Okay, that's really all we're going to work with. Sometimes, if you're not wanting to write fractions, you could actually just say xy is equal to k. And so this gets at that idea of inverse. So if you know that the product has to be constant, if x goes up, y must go down. That's the idea of inverse. So in a table, if we looked at x and y, we would see something like, okay, 1, 2, 3, 4, 5. So we're adding 1 as we go up. And what we would see happen in y is, so this would be something like just, oops, back up. We would see like k, and then this would be k divided by 2, and this would be k divided by 3, and this would be k, oops, k divided by 4, etc. But this is decreasing, right? So this is decreasing, while the other side, x, is increasing. Okay. Graphically, if we looked at this, this would behave something like our reciprocal function. So like y is equal to 1 over x, for instance. So you could have something like, depending on if you have x or x squared, something like this, we would have something over here in either quadrants 2 or 3. Okay. So that's what inverse variation looks like in all the forms, as well as direct variation. Okay. So I want to do one example, and then I'm going to leave you with an example and provide you with another example in the quiz. Okay, so here, volume of blood, blah, blah, blah. Okay, lots of words. Students get confused. But the big thing is, where do we start? And I like to say, well, variation, you need to start with an equation. What is the equation? Well, remember, we have this language, right? And we want to translate the language into algebra. So I want to look for the variation statement. So here's varies directly as, okay, so volume of blood in a person's body. So that's going to be a quantity. And here's the other quantity, body weight. So I need to define these. I'm going to say V is equal to volume of blood. And then W is equal to body weight. And then when I translate this into the mathematics, what I can say is that V is equal to KW. So this language varies directly as, I think of this as equals K times. Okay, so you have, in this case, V is equal to K times W. Okay, and then now the rest of it is giving you information to help you find K and then subsequently solve for whatever they want you to give. So in this case, quarts of blood, so volume. So let's use the second sentence now. A person who weighs 160 pounds, so this would be 160 is equal, 160 times K is equal to 5 quarts of blood. So again, this is in quarts, and so this is in quarts, and this is in pounds. Okay, so then if I divide this, K would be 1 over 32. Okay, so then this really gives me the equation V is equal to 1 over 32W. And now that I have the value of the constant of proportionality, what I can then do is use this to estimate the number of quarts of blood in a person who weighs that. So 1 over 32 times 200, and that ends up being 6.25 quarts. So then again, since it is in a context, I would need to respond in context. So there is 6.25 quarts of blood in the person's body. Okay. Great. So now example 2, I want you to pause the video, try it on your own, and resume when you want to see the solution. Here's the solution to the problem. The big thing is the setup. Once you get the setup, I think everything else ends up going a little bit more smoothly. So again, varies inversely as, so this one had inverse variation, but that's equals to K times 1 over, and then here intensity, so this is I, and then distance, now square of distance is D squared. Okay, and then from there you just substitute stuff in and you can get this. Again, pause the video if you need to verify the solution. Examples 3 and 4, I want you to take a look at these, try and set them up. 4 is, there's a lot of stuff going on. Big thing is make sure to, in each of these, define your variables. Okay, and example 3 is something that we will start off class with. next time. And so make sure to take a shot at it, come with some ideas, and we'll be able to discuss it fully there.